In the previous video, we looked at extracting learning curves and plotting its graph with classifiers. In this video, we will build a classifier to estimate the income bracket of a person based on 14 attributes. Here, we will build a classifier to estimate the income bracket of a person based on 14 attributes. The possible outcome classes are higher than 50k or lower than or equal to 50k. There is a slight twist in this dataset in the sense that each data point is a mixture of numbers and strings. Numerical data is valuable and we cannot use a label encoder in these situations. We need to design a system that can deal with numerical and non-numerical data at the same time. We will use the census income dataset available at archive.ics.uci.edu. Let's now see how we can do this. So let's go to our editor. Here we will use the income.py file already provided to us as a reference. Also, we will use a naive Bayes classifier to achieve this. Now let's import a couple of packages. You can see we've imported packages, i.e. pre-processing from sklearn and Gaussian NB from sklearn.naivebayes. Next, let's load the dataset. So we do this by using this code. Now here we will use 20,000 data points from the datasets, 10,000 for each class to avoid class imbalance. During training, if you use many data points that belong to a single class, the classifier tends to get biased towards this class. Therefore, it's better to use the same number of data points for each class. So, we imported the dataset by using this code. It's a comma-separated file again. We just loaded the data in the x variable just like before. Next, we need to convert string attributes to numerical data, while leaving out the original numerical data, which we have already done here as you can see. The isDigit function helps us in identifying numerical data. We converted string data to numerical data and stored all the label encoders in a list, so that we can use it when we want to classify unknown data. Now let's train our classifier. So we put this code here. Next, we split the data into training and testing to extract performance metrics. So this code performs the cross-validation for us. Now let's extract performance metrics and get the F1 score of the classifier. Let's see how to classify a single data point. We need to convert the data point into something that our classifier can understand. So we added this code to test encoding on single data instances. We're now ready to classify it. Just like before, we use the predict method to get the output class and the inverse transform method to convert this label back to its original form. So this is the line which enables us to predict and print the output for a particular data point. Now let's run the code. Here we get the F1 score as 63.06% and a warning. In this section we have built a simple and a logistic regression classifier. We also saw how to build a naive Bayes classifier, and then we split our dataset. We dived into evaluating the accuracy and visualized the confusion matrix. We then extracted the performance report, validation curves, learning curves, and finally we estimated the income bracket. In the next section, we'll learn how to use predictive modeling for data analysis.